differentiation by rule. So this is when we're going to be differentiated all the time by rule, okay? And again, we'll have the actual examples later, but this is the background, okay? Hugely important bit of these, okay? This is absolutely critical. We're able to do these and we're able to know which one is which, okay? So basically, you know, you have the rule, just straight differentiation by rule, and then you have your product rule, which is multiplying, your quotient rule, which is dividing, and your chain rule, which is when you can't do anything else, you're stuck and you get the chain rule, okay? The huge important thing I'm going to look at here is know which one to use and why, okay? And then we're going to finish off with two that aren't on page 25 of your tables, which I think are worth knowing or definitely being able to do every time, okay? And that is 1 over x and the square root of x. We'll come back to those in a second, okay? So let's just be clear, okay? And I'm going to use kind of not quite correct terminology, but just give us an idea of where we're going, okay? So we're all happy with one like this, okay? Now, I'm not going to do any calculations here. You're going to see the calculations in a minute, okay? So, here we go, okay? So, you can differentiate that straight, okay? So, you know that's going to be 6x plus 2, done. And we'll see how that's done in a minute, okay? And we call it f dash x, okay? And we get our answer. And it's the derivative. It's called a derivative. Make sure you're clear. Understand this term, derivative. Okay, derivative means differentiate, okay? That's fine. Now, when the issues arise is when it becomes more complicated, okay? So let's look at one here. F of x equals x squared plus 3 by 2x plus 4. Now, what I'm going to call these is kind of mini functions, okay? So we have a function here with x. I'm going to call it a mini function. We have a different function in x, another mini function, and we're multiplying the two of them together. If we're multiplying two of them together, we use the product rule. Okay, product rule, and we'll see the product rule in a minute. Okay, you know, u dv dx plus v du dx. Product rule if you multiply them together. Simple as that. The other option you have is you can just multiply out the brackets and go back to this. That's fine too. Okay, but I would generally use the product rule at this stage, and we'll see how we do in a minute. Okay, next one, f of x equals, okay, pretty straightforward. Is the dividing rule or the quotient rule. Get something like this, pretty clearly dividing. It's more complicated than this, so it's either the product rule, the quotient rule, or the chain rule. Okay, this is clearly a quotient rule, dividing rule. Okay, we call it top one u, the bottom one v, and we go on as we'll see in a minute. Okay, should be fine. So we have a mini function divided by a mini function. That's fine. Okay, so they're fine. Okay, and then the other one is if neither of those work. Okay, if none of those three, if you can't do it, if it's not a simple one, if it's not multiplying rule, it's not dividing rule, it's the chain rule, okay, and that's the size of it. Okay, so if we look at a chain rule one, okay, right, so we get 3x squared plus 4 to the power of 11. Okay, so clearly, okay, first of all, it's not straightforward, okay. Secondly, it is not multiplying rule, because you're multiplying the bracket 11 times, not too many brackets, okay, it's not the dividing rule, so therefore it has to be the chain rule, simple as that, okay. Now if it's a chain rule, right, I have a method, okay, now so many ways of doing this. If you can do your chain rule by your own method, fine, okay, otherwise have a look at this one, okay, so it's just another way of looking at it, okay. So what I say all the time is differentiate inside the bracket multiplied by differentiate the bracket, okay. And we'll see this in action now in a minute in the next section, but we're going to do this one, okay. So f dash x, now what it means by differentiate inside the bracket, well that's fine, you just differentiate what's in here. So in this case that's 6x, and I'd always put it into a square bracket to make life easier for us. Okay, and then you multiply by differentiate the bracket. Now differentiate the bracket catches people out. All that means is, okay, let's take an example. If I say differentiate x cubed, you know it's 3x squared. If you're differentiating t cubed, it's 3t squared. If you're differentiating elephant cubed, it's 3 times elephant squared. Okay, if you're differentiating bracket cubed, it's 3 times bracket squared. And we talk about the bracket, okay, all we're talking about is the whole bracket, and you leave what's in the bracket, okay. So basically to differentiate that bracket, it's 11 times the bracket to the power of 10, and you put whatever is in the bracket into the bracket, and you then can multiply. So you just here we're getting 66x by 3x squared plus 4 to the power of 10, and we're done. Okay, that's how you do it. That's the chain rule. Now, sometimes it's kind of hiding. Okay, so let's take a situation like this. Sine of 5x. If you're asked to differentiate sine of 5x, you look at this. Now, from page 25, as we'll see in a minute, okay, we know the differentiate sine of x is cosine of x. So let's go back to here. Sine of t will be cosine of t. Sine of elephant, cosine of elephant. Sine of bracket, okay, close to the bracket. Okay, so let's go back to this. Differentiate inside the bracket. So we have here, differentiate inside the bracket is easy. That's 5. Differentiate the bracket. Cosine of bracket. Okay, and we end up with 5 cosine of 5x. Okay, so that's that. Okay, so that's, so I think go through the examples. You can all do them. Okay, multiplying rule, dividing rule, chain rule. So in other words, if there's no difficulty, differentiate by rule. If you have to multiply, use the multiplying rule. You have to divide, dividing rule, and if you can do none of them, chain rule. Okay, right. 2 I want to look at very briefly. Okay, to finish. Okay, to be able to do these if they come up, or I would always know them if I was you as well. Okay, so you can just slot them in if necessary. Okay, but I'm going to go through them in full here now. Okay, and the first one is, okay, square root of x. Okay, so square root of x. Now, so watch how we go about this. Okay, we write it as a power, and you know square root of x is x to the power of a half. Right? To differentiate it then, this is straightforward. Okay, there's no multiplying rule around like that. So we're just following the rule, but be careful. So it's a half of x to the power of minus a half. Okay, now come back to our algebra later. Okay, remember x to the power of minus a half. You can bring that below the line, changes to x to the power of a half, doesn't it? So 1 over 2x to the power of a half, and then we can change that back because we don't like x to the power of a half. It's ugly. We use square root. Okay, so it's the square root of x. Okay. Now, I would know that if I was you. Okay. Okay, f of x is root of x. F dash of x is 1 over 2 root of x. It's one I'd learn off. Okay, but I'd also be able to do it if necessary. Okay, and the same applies to the other one that I think is important to be aware of, that catches people out, 1 over x. Okay, same method. Okay, I'm going to write it as an x to the power of, so we know from our indices that's x to the power of 1, so it becomes x to the power of minus 1, and if we differentiate, we apply our normal rules, so minus 1 times x to the power of minus 2. And then at that stage, we don't like x to the power of minus 2 in a finish, we just use, we're happy to use it, so we bring it below the line. Okay, and it's minus 1 and it changed to the power of x squared. Okay, so if you differentiate 1 over x, you get minus 1 over x squared. Be able to do it like that, but then also I would suggest learn the 2 of those. Okay, I think it would be much nicer if they're on page 25, but they're not on page 25, so we have to make it do. Okay, look at the calculations, figure them out, do your problems, see if they're right, and drive on. Okay.